So today let's start with this basics of current electricity, and in that I'll first start with the problem solving of circuits, which you must be aware of that earlier. Also, you must have done that. But we'll revise that, the basic concepts and the topics which are left in the first chapter, that is about potential and capacitors, that we'll do later. So for today, let's start with this electrical circuits. So as you can see here in electrical circuits, we have few elements in this circuit, right? The first one is this battery. So what exactly is battery or cell, or what does it do? So a battery will have this terminal is positive and this terminal is negative. The terminal which is shorter one, that is negative. The current starts flowing from positive and it enters into negative direction. What exactly is current? So this arrow direction shows the direction of current. Now what exactly is current? So current is nothing but direction opposite to that of flow of electron, right? So the electrons flow, and direction opposite to that flow, or that direction opposite to the direction of electron flow, that is nothing but the current. And this is also numerically equals to I is equals to dq by dt, or delta q by delta t. So current is represented by I, and its unit will be amperes. So that is about current. Now question is how battery, or how battery causes a current. So we'll see that now. Our battery, which is like this, is source of potential. So what exactly is potential? Potential is, in normal English, we know what is potential, right? It is capacity. It is some, you can say, initial hidden potential or hidden capacity or talent. All those things are named for potential. So the same thing is here in case of electrons. So negative terminal is called negative because there are electrons here. It is an electron rich area from which electrons start coming out. So this green arrow is direction of electron flow. But if electron has to flow from here, it cannot flow on its own. And we have studied earlier that if an electron wants to flow, it can happen only if it experiences a force. To experience a force, there must be a electrical field established. So what happens if there is an electrical field? If electron travels from here to here, between these 2 points, there is a potential difference, potential at A and potential at B. That's how we'll denote it. And VB minus VA is equals to potential difference, right? And the amount of work done is equals to Q into delta V. That is the amount of work done. Or you can say this is the amount of energy consumed in moving from A to B. So this is the amount of energy consumed. Potential actually is that, you can say, source of energy. So this electron wants to move and come back to this point. So, and along a path. So for this, it will require some energy. So who will give this energy? This battery. So potential is given by battery, and it is the, you can say, the amount of energy to be consumed inflowing electron from one terminal of battery to another. So this is called positive and negative terminal. Okay, so this is the positive terminal, this is the negative terminal of the battery. So electron is leaving from negative terminal and it is reaching the positive terminal. Obviously some amount of work has to be done. That energy it must take from somewhere, and battery supplies that energy, right? And energy per unit charge is nothing but potential. So battery, the energy which is it going to consume, that we calculate in terms of potential. So that means what? If suppose this is a 10-volt battery, that means here the amount of energy electron will have will be equals to 10 volt. And when it comes from here, here, here and reaches here, then here it consumes all those 10 volts and here it is just 0 volt, right? So this is the thing which we have to understand. So what we have studied till now is, suppose this is a closed path, electron starts its journey from here, but in order to study current we don't take electron into picture, we actually study positive charge. So if an electron moves from here to here, that means there is a positive charge which is moving from here to here, that is in opposite direction. So that means positive charge is moving from here to here. So what we saw earlier was direction of electron. Now this is direction of current, which is nothing but opposite direction of, you can say, electron, or the direction in which the positive charge must have been moving. So this is the positive charge which is moving, and if this is 10 volts battery, that means here the potential that charge has 10 volts, and that it starts consuming. So because it has to travel, right, in all these path, so that energy is consumed, and when it reaches here, it reaches with 0 volts. Now, where is that energy consumed? So in order to consume that energy, or where it is consumed, is actually every conductor which conducts electricity also tries to resist the current, because obviously it is the electron tries to flow through it, so someone should be there to, I mean, it won't allow it that naturally. And to overcome that, it has this 10 volt of initial energy, and it will try to spend those 10 volts of energy in these, say for example, in these 4 resistance, that 10 volts of resistance, 10 volts of initial potential will be consumed. So these things, they have tendency to oppose the current, and that's why these things are called resistors. So they'll have different capacity, that in order to cover or in order to cross this resistor, some amount of energy will be required. That amount of energy, in terms of, instead of energy, we'll say in terms of potential, something will be consumed out of the 10 volts. So suppose this here consumption is 4 volts, here consumption is 2 volts. So 4 plus 2, 6 volts have been consumed. Here consumption is 1 volt. That means now 7 has been consumed. So here, how much will be left? It will be only 3 volts. So that 3 volts will be consumed here. So started with 10, consumed 4, 6 left, consumed 2, 4 left, consumed 1, 3 left, consumed 3, 0 left. So that is the basic fundamental of how electrons or how current flows and how the potential is getting consumed in crossing the resistors. Right? And now there is a relation between V, I, and R. that is based on Ohm's law. This is possible only if a conductor follows ohmic law, right? So we'll study what is ohmic law and what is non-ohmic conductors later, but for the time being, this is our law, that is V is equals to IR. This is the Ohm's law. Okay, so that means it's simple. If I current flows through this resistor whose resistance is given by R, then some amount of potential will be consumed here. Suppose this is VA, this is VB. That means VA, with which this current entered here, minus VB, the potential with which the current is leaving from here, that will be equals to IR, or delta V is equals to IR. This is also called potential drop. Potential drop, right? So that means here it may have entered with 10 volts. Here it may be leaving with 2 volts. That means the amount of potential which is dropped here, that is actually 8 volts. So 8 volts have been dropped or have been consumed, or there is a potential drop of 8 volts in the above example. And what do we have? This relation. That means that drop is equals to I into R. So whatever is unknown, out of three things, two should be known, one unknown, and we can find that unknown value. Right? That is the basic understanding of current. Now there are two rules about current, which is this is a point where two current carrying conductors are meeting or intersecting, right? Meeting point of multiple or meeting point of different directions of current. That is called a junction. Junction is a point where there are multiple paths available. Okay, now at this point, suppose there is something else. Now suppose here on this junction, say junction is P, there are current coming from in this direction and current coming in this direction. Say that is I1 and this is I3, and current going in this direction, that is it is moving away from here. Say that is I3, and here this is I4, this is I2. So on this junction, the current which is coming, right, that is incoming current. Total incoming current is I1 plus I3, and at the same junction, outgoing current is I2 plus I4, and current is nothing but flow of charge, right? And there is something called law of conservation of charge. So the same law holds here true. So law of conservation of charge, the same law holds true here as well. So due to that law, we conclude that I1 plus I3 is equals to I2 plus I4, or in short, total incoming current is equals to total outgoing current. That is the first law or first rule. This rule is called Kirchhoff's junction rule. Okay, and we can see the application of this. I mean, if you have understood or not. So suppose at this junction, from here and here currents are entering, and here it is leaving from the junction. Junction is this. So if it is 10 ampere, this is 2 ampere, this is 3 ampere, then this will be equal to what? So this will be equal to 9 amperes. So 9 plus 3 is equals to 2 plus 10. So that rule is called Kirchhoff's junction rule, which is based on law of conservation of charge. So this rule is actually based on this law of conservation of charge. Next, as we have already seen earlier, that total potential gain is equals to total potential loss or drop, right? That is in for us to understand what exactly that means. Suppose this is something and the current is moving in this direction. Suppose the current is 10 ampere and this is 2 ohms. And we know that delta V is equals to I into R. So I is given, R is given. So that means I can find what is delta V. So what will be delta V here? That will be 20 volts. So that means from here, if the current is moving in this direction, then from here to here, there will be a drop of 20 volts. So suppose if this point, the potential is 50 volts, then at this point, the potential will be equals to 30 volts. And what does it mean? It also means that if the current is flowing in opposite direction, so not the current, this shows that from here to here, there is actually gain in potential, right? So here, this 20 volts is drop, but here, if I'm coming from here to here, this 20 volt must be gain. So that's what we say, that's what we have to first understand, that if we are going in the direction of current, then we'll be losing our potential. And if we are coming from the opposite side, in the opposite direction of the current, this is not the direction of current, this is opposite direction of current. So there must be a gain in potential, right? So why? Because if there is 30 volt here, there must be 50 volt here, which we have already seen here. So there is a gain of 20 volts. Here there is a loss of 20 volts. So this we have to understand in actual circuits. For example, in this circuit, there can be multiple cells. Suppose this is one cell, and suppose there is another cell like this, and suppose there is cell in opposite direction here. Okay, now suppose there is a resistor here. Resistor I am drawing red just to show that it is resisting or opposing the current. Suppose it is given that this is 10 volts, this is 2 volts, and this is 3 volts. So now it's up to us. We can start from anywhere. Suppose we start from here, that this is the direction in which current is moving. That is I. So what did we say? We said that if something starts from here, it will start with 10 volts. And because you are moving in the direction of the current, you keep on moving like that. No issues. But if you see here, there will be a drop in current. Sorry, not drop in current. There will be a drop in, there will be a drop in voltage, right? Okay, suppose this is 10 volts, 2 volts, and 3 volts. We have already written. This is 2 volts. What does that mean? That here, if the potential is 2 volts, at this side, the potential will be 0 volt. That means if I'm moving from here to here, there is a drop of potential. And what is here? If this means that here there is a 3 volt potential, then here there will be 0 volt potential, right? So these things we have to take care that where it is. So that means if I am moving from here to here, there is a rise in potential or there is a gain in potential here. So this we have to understand. If the current is still flowing in the same direction, then again here there is a drop, and again current is flowing in this direction. That means here also there will be drop. So that means we started from 10 volts. So this 10 volts, there is no current here, but there is a drop. There is no resistor still here, but next at this 2 volts battery, there is a drop. So that is nothing but mine. That is because it is drop, so I am showing it as negative. So 10 minus 2. Then minus I into, suppose this resistance is R1, this resistance is R2. So I minus R1. Then if you see this one, there is a gain. So what I'll show it here is plus 3 volts. Then again minus I into R2. So this total should be equals to 0. You can say the initial pocket money with which it started, right? That was 10 volts and it has spent all that 10 volts here. So his income was 10. All these are expenditures. So ultimately, whatever he has started with, he has lost everything. He means here charge or current or anything. So that's why this is the relation. This is called Kirchhoff's voltage rule or loop rule. So it's a closed path. So again, what can I write for this? That total potential drop in a loop is equals to 0. You keep on adding all the potential drops, taking negative and positive, then ultimately you will end up getting 0. Total drop is equals to total gain. So these two are two different rules. Right. So now next is two different combinations. Two different combinations which you must have studied. That is series and parallel. Question is how to identify when two circuits or two resistors are in series or are in parallel. So in books and all, you will find, or some books, you will find some definitions like, if there is end-to-end connection, then this is called series. And if two ends are connected together or otherwise, that is called, the other connection is called parallel. So for simple circuits, it is okay. But if the complexity increases, this is little difficult and this will not always give us the correct answer. So there should be proper definition for, or proper difference between series and parallel. So what exactly is series? Series is when there is no distribution of current. So if you study this Kirchhoff's junction rule once again, so if 10 amperes is coming here, so now from here there are two branches, so both cannot have 10 amperes. That's what the junction rule was. So here, if it has 4 amperes, that means here there will be 6 amperes. So current is divided. So whenever current is divided, we say that there is a possibility of getting parallel configuration. And when there is no division of current, so what is here? There is a division of current. And if there is no division, then that is series. Series means no division of current or no branching. Right? This becomes clear when we, this thing is just like, and why we say that in series there is no division and all. Suppose there is a water pipe like this. This is pipe 1. And then again next, suppose this is pipe 2. Okay, so when we have pipe 1 and pipe 2 like this, so whatever charge, whatever water comes here, if it is say 4 liters, so at the end you will get all those 4 liters. There is no division of water here because there was no branching. This is called series. But if it is in some other way, suppose here and here there is a T joint. So now water starts flowing in this direction as well as in this direction. And suppose from here you are entering that 4 liters and here you are getting only 1 liter. That means here you will get 3 liters. This is called parallel. This is not series, or you can say not series. So that is the basic difference between parallel and series. Now, obvious thing is, if I ask about resistance to flow, what about resistance to flow of water in this case? Resistance to flow of water in these different cases. Here, obviously, the path the water has to complete has increased, and every path has a resistance. So this resistance is getting added up. The opposition by the pipe to the flow of water is getting added up. Or we say that that is increased. But if you see the second part here, so basically there is traffic from this direction and this traffic got diverted in 2 different directions. So what will happen now? Obviously, the opposition to that traffic is now decreased. So we say that in this case, the resistance or opposition to flow is decreased, right? Okay, now we understood what is series and parallel, and now we'll see how to find effective resistance in case of series and in case of parallel. So that is effective resistance. Suppose we take an example of series combination, and there are three resistors like this: R1, R2, and R3. So you must have solved problems based on the circuits in which there are lots of resistance and cells and all those things. So we'll see why we do that. What is the purpose of doing that? Why, before just going into and solving such problems, we should know what is the purpose of the thing which we are studying. So here, suppose this EMF of the cell is E, or you can simply take it as potential. So EMF is the potential of cell without any internal resistance. We'll understand that also later. And suppose there is a current flowing in this direction, and that current is I. So that means what? E is the potential with which the current starts, or with which we start from here, with potential what? E. And then what is happening here? There are some drops here. That is V1, V2, and V3. These are the drops. And what do we know about all these drops? That this V is equals to V1 plus V2 plus V3. Let us call this as V. So it started from V, and so this was your input and this was your consumption. So ultimately all of this should be consumption, all consumption together should be equals to the input voltage. Right? Now, what is the purpose of this effective resistance doing here? So purpose is that we want to find, instead of using three different resistors, if I want to use only one effective, if one resistor whose effect or whose impact is same as the combination of these three, is it possible? So that's what we are going to do here. So we say, okay, supply is anyway same, which we have here. So its impact should be same means what? The current should be same. So if the current should be same, then what should be the resistor here? That's what we have to find. That is the purpose of solving such questions, right? So this is our, or this you can say that this is the effective equivalent circuit. That is circuit which is equally effective as the previous one. So what should be the value for this R? Right? So that's what we say, and that's what we actually find here, and we find the equivalent resistance or effective resistance of these three resistors. If they are connected in series, then what will happen? So we'll see here. V1, that is drop 1, is equals to I into R1. Now that's what series or definition of series comes into picture. Because there is no division or there is no diversion here, so same current I will flow through all the resistors, right? That's what is law of conservation of charge. There is no deviation. So V1 is equals to this, even V2 is equals to I into R2, and V3 is equals to I into R3. That implies that total potential drop is equals to I into R1 plus R2 plus R3. Now come to the second part, that is this effective circuit. In this effective circuit, what do we see? We see that instead of R, there is a, instead of three different R's, there is a single R, which should act as this combination. So, and in here, if I have to consider this, that means V is the initial source input, you can say, and here there will be a drop, and that drop will be I into R, and that drop should compensate the initial potential. That means this V in its equivalent will be equals to I into R. So from here, if we compare, that means what is R? R is equals to R1 plus R2 plus R3. And looking at the, we can say that, looking at this condition, we can say that the total resistors, if all the resistors are in series, series is where the current is not divided. As you can see here, the same current I is here, same current I is here, and same current I is here as well. So the current is not getting divided. That is called series. And in that series, this will be the equivalent resistance or effective resistance of a series circuit. Now come to parallel. So parallel is when current divides or where there is branching. Or we can say that when current divides, that means, say for example, this is happening somewhere. That means what? If I is here, there will be I1 current here, and there will be I minus I1 or total I2 somewhere over here. Correct? Okay. Now, when the current from here comes to this point, so this point is common between this. So if a charge is here and another charge is here, and charge comes to this point, then here they both charge will share same potential. So suppose here it is VA, here it is VB, and current is flowing in this direction, and Q is the positive charge. So at this point, VB will be same for both I1 and the current flowing from the upper direction or from the lower path. They both will have it, will be at same potential. So that means what? Across this combination where current divided, across this, even delta V is constant or same for all the path. Constant or same for all possible paths. What does that mean? Suppose here, suppose at this point we have 30 volts, and at this point we have 10 volts. And suppose a charge is coming from the upper direction. So that means what is the loss for that? 30 minus 10. That is actually loss of 20 volts. So that loss here also has to be 20 volts. It cannot be less than or greater than that, right? Because here and here we can have only 1 and 1 values. Now based on this, we can solve some very basic thing first to see whether we understood or not. Suppose from here, the current is coming, say that is 10 ampere. This is 2 ohms. Current which is coming is 10 amperes. This is 2 ohms. This one is say 4 ohms, and this is also 4 ohms. What does it mean? That first one will have least resistance because that is only 2 ohms. Second and third will have same resistance to the current which is coming here. So that means what? Obviously, because here the resistance is less. So in these, there will be three different or let us say there are three different currents, I1, I2, and I3. So what can we say about I1, I2, and I3 in terms of their magnitude? So if we see here R1, R1 is less than R2, which is equals to R3. So that's why, because these two resistors are same, so the current also which will be flowing there will be same. That is I2 will be equals to I3. But where will be the current more? So the answer is this, because here the resistance is less. So I1 will be more than I2, which will be equals to I3. So this is the first thing which I want you to notice, that current will be divided. And the way current will be divided, just opposite will be the division in, you can say potential drop. Sorry, potential drop is going to be same, right? So let's say here I have, in this case, as I said, 10 ohms given. So it is 2 ohms here. So that means that 10 ampere, and this is in the ratio 2 is to 4 is to 4. So the same opposite ratio. That means here if the current is I1, so between I1 and I2 there is a relation. I1 is double of I2, right? Or double of I3. So this is the ratio in which the current will be divided. Total current, that means if I1 is equals to, that means if I1 is equals to X, I2 is equals to X by 2, and I3 is equals to X by 2. That must be clear from here. Resistance is double. So the current will be half. What does it mean? That I1 plus I2 plus I3 is equals to 2x. But what is this current total equal to? This is actually equals to 10 amperes. That means x is equals to 5 amperes. So that means here the current which is flowing, that is 5 amperes. That means here it will be 2.5 amperes, and here also 2.5 amperes. Done. Now due to this, what is the potential drop here? That will be the current which is flowing through this and the and the resistor. So that is equals to 5 ampere into 2 ohms, or that is equals to 10 volts. Now see here, if you multiply these two, again you will get what? 2.5 into 4. So what is that? That is also 10 volts. Here also you have 10 volts. So that should be clear, that how the current is divided. And what we observe is that in parallel there are two things. First, current divides. Second, potential drop remains same. So two conductors are in resistance only if their potential drops remain same, which we saw here. What is the potential drop in all these cases? 10 volts, 10 volts, and 10 volts. Now we'll see how to calculate this combination of resistors. So this is the special case which we saw, that resistance gets divided in parallel. So if two resistors in parallel are say 9 ohm and 9 ohm, so their equivalent will be 4.5 ohm, or 9 by 2 ohms. If there is 15 ohms and there are, suppose, 5 such resistors, all of 15 ohms are connected in parallel, then their equivalent will be 15 by 5, which is equals to 3 ohms. So that's how we calculate resistance in series or in parallel, equivalent resistance in series or equivalent resistance in parallel. And there can be circuits in which we have both the combinations of series and parallel. So let's try to solve one such problem. So there are resistances here, and we have to solve this. And suppose the resistance are also given, that is 1 ohm, 1 ohm, 2 ohms. Sorry, yeah, 2 ohms. This is 1 ohm, this is 2 ohms, this is 1 ohm. Okay, and suppose we have to find whether the equivalent resistance for this circuit. So now see this carefully, and suppose this is also 2 ohms. So we have to find what is RAB, the equivalent resistance between A and B. Now, sometimes or few students get confused and they take this and this in parallel, seeing the diagram like this. And that's why I said we will not go by that definition. Our definition is current getting divided? Answer is no. So that means what? These two resistors are actually in series. So if they are in series, what we are going to do? We are going to just add them. So the equivalent of these two will be what? 1 plus 1, 2. So how can I write? And then what? Then if you see this and this, in this and this, current is getting divided. So that means the equivalent of this, which will be equals to 2, right? That will be in parallel to this, which is equals to 2. And they both are meeting at the same point. So these two are in parallel. Is it clear? So this was 2, this was 2, and after that there is this one. We are talking about this. This is 1. And then we'll take it further later. So these two now, which is this 2 and 2, which is in parallel, and they are 2. So this will be actually 2 by 2, that is equals to 1. So the equivalent of these two will be 1. That means in the original, actually, this equivalent is 1. And that one is again in series with this 1. So that again 1 and 1 will be 2. And then that 2 and this 2 will be in parallel. So that 2 and this 2 will give us 1. And then that one and this one are in series. So these together will be 2. So equivalent of all this above is 2. And then this 2 and this 2 are in parallel. So the equivalent of these two will be 1. So our answer will be 1. That is 1 ohm. So that's what we have to, the thing which we have to see here is that this, don't get confused. And this is the very, very basic of this identifying series and parallel. that only if the current is being divided and the two resistors meet at their beginning as well as at their end, or the two different endpoints are same, then only we'll say that they are in parallel. Otherwise, if there is no division in current, then that means the two resistors are in series. Okay, so that is how we are going to identify whether a circuit or whether two resistors are in series or parallel. And in our exams, the questions may be given not directly. For example, you may get something like this. So there is a resistor here and there is a resistor here. It's in form of a circle, that's all, nothing else. But what do we know? That this is 2, if this is given 2R and this is also given 2R, and suppose we have to find between these 2 points, that is A and B. So what do we know about this 2R and 2R? They are in parallel. So the equivalent resistance will be 2R divided by 2, that is equals to R. This is the equivalent resistance. Simple. So few more examples. Let's see. Here there is a 2-volt battery. This one is 30. This one is also 30. And this is also 30. This is triangle A, B, C. Okay. And the current, suppose, yeah, obviously it will flow in this direction, that is from positive terminal. So here we have to find A. So it's not like always you have to calculate the equivalent resistance. That may be part of the solution, part of the question. And here it is, you have to calculate value of A. Okay, so how are we going to do that? Again, don't get confused. What do we see here? Whatever current is coming here, the same current will flow through this. There is no division at this. This is not a junction. This is just a path. Actually, they should write it like this to simplify it, but they have not. So this is 30. This is 30. And this is 30. There is no division between these two 30s. So if it is given like this, you won't get confused. But if it is given like this, in case of in shape of this triangle, most of the students, they get confused. And that's why this question used to be asked in IITs earlier. So what we see here is there is no division. No division means these two are in series. So if these two are in series, what are we going to do? That means these two together will be equals to 60. Just add them. Now what do we have? We have this. One is 60, one is 30. So 1 by 30 plus 1 by 60. And even for this, let us see a general result. So if it is R1, R2, so it will be 1 by R1 plus 1 by R2. That is equals to R2 plus R1 divided by R1, R2. So from this, what do we conclude about R? R is equals to R1, R2 divided by R1 plus R2. So equivalent of this 30 and 16 parallel will be what? R1, R2 divided by R1 plus R2. That is equals to 20 ohm, right? 33 is a 90 and then 20 ohms. So that means this entire thing is actually only 20 ohms. and you can see that 20 ohm is their individuals are 30, 30, 30. It is actually less than their individual resistance. So in parallel, resistance decreases. So now 20 ohms is the, so this is the equivalent diagram. This is 2 volts. This is 20 ohms. So the current which flows here will be equals to what? That current will be equals to V by R, that is equals to 2 divided by 20 amperes, or just 0.1 ampere. So that's how we solve such questions. You have to, you just have to take care of this thing, that you don't get confused between the series and parallel. That definition should be clear. So 60 volts here. This is R1, R2, R3, and R4. R2 and R4 are 10. R3 is 5, and R1 is 18. And what do we have to do here is, again, we may have to find the current, determine the voltage drop across. Okay, we have to find the voltage drop across R1. So what is this drop here? What else? That means, again, if you have to find that, what is voltage drop? Voltage drop is equals to I into R. So you have to find I, because you already know what is R. So you must know what is I here. Okay, so in the circuit, and that is what we have to find. So again, indirectly it is given. You have to find current. You have to actually find V, this thing, the drop. But for drop, you need this current I. And for this I, you need the total equivalent resistance of this circuit. So no issues, we'll do that. But as I said earlier, identify and simplify. This here, there is no division of current. That means these two are actually in series. So just add them. That is actually 15. Right? Now see R2 and this combination, which may look like this. You have R2 here, and you have another resistance here. Right? Say that is R5, which is equals to 15. Now these two are in parallel, because here you can see they have common ends, right? And the current is getting divided. From here, current will get divided. So that's why these are in parallel. So what will be equivalent of this? Suppose that is R6, that will be equals to R2, that is 10 into 15 divided by 10 plus 15, that is 25. So that is equals to 6 ohms, right? That means this entire thing is equivalent to only 6 ohms. And now that is in series with this. So total R equivalent is equals to 18 plus 6 equals to 24 ohms. And what is the V value? That is equals to 16 volts. So from here, what will be I? I will be equals to V by R, which is equals to 60, that is V, divided by 24. So that will come to be 2.5 amperes. Right? So that is 2.5 amperes current. But what do we have to find? We have to find the voltage drop V1. So that is equals to I into R1. So that will be equals to 2.5 into 18 or 45 volts. Now we can find others also which is not being asked here. So total voltage drop is how much? Across V1 is how much? I mean here it is 45 volts. So we started with this 60 volt. Out of that 45 volts is dropped here. That means how much is left? 15. So that 15 is covered here. And if you see this point and this point, there are two different paths, but the endpoints of two different paths are same. So that means here also it is 15 volts which is consumed, and here also that 15 volts is consumed between R3 and R4. But one must have taken more and other must have taken less. So the same 15 volts will now get divided here in the ratio of what? Resistor is in ratio 5 is to 10. So the voltage will be in the ratio 2 is to 1. So in the same ratio, that is in ratio 1 is to 2. So 15 when divided into 1 is to 2, here you will get 5 and here you will get 10. So 5 volts will be dropped here, 10 volts will be dropped here. So that's how we can find individual potential drops as well. 45 volts, this path also 15 volts, this path also 5 plus 10, 15 volts. So 45 plus 15 total, 16 volts gets consumed. So that's how we solve such problems. Like we can also find current in the individual circuits. We can also find voltage drop across individual resistors. So what is left now? Suppose we have to find current. So current here is how much? What was our current value? 2.5. That is 5 by 2. So the same current will get divided here. But in what ratio? The ratio is here resistor is 10 and here resistor is 15. So when we have to find individual currents, how can we find? We'll see that it is given that there are two paths. One is having 10 ohm of resistance, other is having, what is the resistance here? That is, I think 15. It was 15, right? So 15 ohms resistor here. And the current which is coming here is say 5.2 ampere. That's what we saw there, right? Now, how to find these individual currents? First way is just divide them in this opposite ratio. The resistance, more the resistance, less the current. So the ratio will be opposite. We can do in that way as well. So it is in the ratio 2 is to 3. So you have to divide 5 by 2 in ratio 2 is to 3. That is 2 by 5. And another will get 5 by 2 into 3 by 5. So this is equals to 1 and this is equals to 1.5. And you see, total should be 2.5 because you are dividing 2.5. So one is having 1 and another is having 1.5. So where will be 1.5? Where 1.5 will be here. And where will be 1? It will be here because here resistance is more. This is one way of doing. Another is we also know the potential drop here. That is delta V is equals to 15 volts. This I think we are aware of, right? So 45 volts is gone here. So here the potential drop is 15 volts. So we can use that as well. So 15 volt is this, and we know that that is equals to I into R. R is how much? 10. So what should be the current here when we know the potential difference? Suppose this is R1. So that means this 15 volt is equals to I1 into R1. Okay, I1 is something which we have to find out. it should be 1.5, but still we have to find out by this method. Into R1 is 10. That means what is I1? I1 is 15 by 10. How much is that? 1.5. So whether we do it like this or we do it like this, we get the same answer. Same way for other. That is the second, for this section, the 15 volts is equals to I2 into R2. R2 is how much? 10. So that means R2 is 15, sorry. So this is equals to I2 into 15. That means what is I2? 15 by 15 or 1. So even by this method, we got the same answer. So these are the two ways of finding the resistors, finding the equivalent resistor, and in this case, the current through the different branches of a parallelly connected resistors. So it's up to you, whichever, and in that situation, whatever is easier, you try to apply that. So in this circuit, in these simple circuits, by the method of equivalent resistors, we have seen how we can find individual currents, individual potential drops, total potential drop, and yeah, all these things. Okay, so that's all about the this portion of the current electricity. Later we'll see other topics as well, and before that